In this video, we're going to use the fundamental theorem of calculus to find the derivative of an integral function. It says, given f of x below, find f prime of x, and they give you f of x is equal to x, the integral from x to 5 of 3t to the 5th minus 3t to the 4th plus 2 dt. So the fundamental theorem of calculus states that if f of x is continuous over ab, then capital F of x, when it's equal to the integral from a to x of f of t dt. So f of x is continuous over a from a to b, then f of x is equal to the integral of from a to x f of t dt, then f prime of x is equal to f of x. So when I take the derivative of f of x, I get just the original function that was in there, but with x as its variable instead of t. Well, that's true when I am going from a to x, but what happens when we flop the upper and lower bound? You can see that the upper and lower bound are flopped here. Well, all that tells me is that instead of, if I were to rewrite this, instead of it being f of x is equal to a to x, we have integral, we would write this as like negative, we'd have integral x to a, f of t. So then when we took our derivative, instead of it being then f prime of x is equal to f of x, this negative piece would actually make it so it's negative f of x. So what we need to do is we need to say that, all right, f prime of x here, and actually before I write f prime of x, let's just say f of x. We're going to flop these by saying f of x is equal to negative integral. Let's switch these out. So we have 5 to the x. This would be 3t to the 5th minus 3t to the 4th plus 2 still. Well, I know this part, okay, fits my formula here. So I end up with just f of x written here. So I'm going to end up with f prime of x is just equal to negative 3x to the 5th minus 3t to the 5th, or t to the 4th, plus 2. So f prime of x is equal to negative 3x to the 5th plus 3t to the 4th minus 2. So when you flop the lower bound and upper bound, all that's going to do is switch the signs for the function from, if they were positive before, to negative.